Okay, now we move to another application of double integrals, which is finding the surface area. So recall, meron tayong two ways to represent surfaces. One is using parametric surfaces, and two yung Cartesian equations natin in three variables. So dahil dyan, magde-derive tayo ng dalawang formulas for surface area. So first, let's recall, a parametric surface is the set of all points in space that can be described by a vector function with two parameters. So yung idea dito, yung points in the UV plane via this R of UV, every point dito sa UV plane corresponds to some point dun sa parametric surface natin. And vice versa actually. Every point sa parametric surface corresponds to some point dito sa UV plane natin. Okay, so ang gagawin natin, kukunin natin yung surface area nito. Well, hindi yung buong thing kasi possibly infinite to. So instead, we have this following scenario na portion lang ng surface ang kukunin natin. So we let S be the portion of this whole surface defined by R of UV, where UV is just over a region D in the UV plane. So imbis na buong UV plane, we just consider a region D in the UV plane with the following assumptions na yung D is closed and bounded. This portion S is smooth. In other words, RU cross RB is never the zero vector for all UV in the region D. And points in S are traversed precisely once as UV varies in D. Ibig sabihin lang nun, yung S natin, itong surface na to, does not overlap itself so that walang double count na surface area. Okay, so we will derive a formula for the surface area for such a scenario. Okay, so ang gagawin muna natin, we first subdivide this region D into subrectangles. In doing so, masasubdivide din yung ating surface into smaller parts. So yung smaller parts dito, tatawagin nating patches. Again, yung smaller parts sa D ay subrectangles. Okay, we let D sub K be the subrectangles. Okay, and S sub K be the patches in S. Okay. Next, let's consider an arbitrary dk and sk. With that, let's also let or we consider the lower left corner of d sub k. Okay, let's call it uk vk. In addition to that corner, consider din natin yung dalawang corners na adjacent dito sa corner na to. By moving, which is obtained by moving delta u units to the right, tsaka delta v units upward. Tapos, again, points sila in the UV plane, so may corresponding points sila sa surface. So, let's say na yung UKVK, this yellow point, corresponds to this point. This purple point corresponds to this purple point, and this green point corresponds to this green point. Okay, so next, ang gagawin natin, i-approximate muna natin yung isang S sub K. Ang gagawin nating approximation ay, we will approximate it by a parallelogram. A parallelogram with these two vectors as the adjacent sides. So take note, itong vectors na to, galing lang sa difference of two vectors. Okay? Head minus tail lang. Okay. So before we derive a formula for the surface area of such a parallelogram, let's recall some topics from calculus. So una, R sub u is by definition is the limit of this difference quotient as delta u goes to 0. So definition lang ta. Okay, tapos using the general concept of limit to as delta u goes to 0. So if we replace delta u by something near 0, or in other words, if delta u is small enough, then yung expression na to will be approximately equal to dito sa left-hand side, or magkalapit sila. Ayan, so we have this approximate equality. So from that approximate equality, cross-multiply lang natin yung delta u. We have this. And replacing AB by the point UK, VK. So we have this, again, approximate equality. Take note, itong left-hand side, isa to dun sa vectors nung parallelogram natin earlier. Okay, similarly, if we consider R sub V, using the definition R sub V, we have that if delta V is small enough, this difference here is approximately equal to this expression. Next, recall din natin from Math 22 na a parallelogram with adjacent sides defined by the vectors A and B, that parallelogram has area norm of A cross B. Okay, so with those, let's again approximate the area of S sub k by this parallelogram with adjacent sides, with these two vectors as adjacent sides. Okay, so for sufficiently small delta u and delta v, or for delta u and delta v that are near 0, we have the following. So etong approximation na to, ang area ng S sub k, approximately equal dun sa area nitong parallelogram na to. Well, approximately equal lang kasi hindi naman, yung parallelogram, kung di isipin yung flat surface yun, yung S sub k, portion siya ng S. So, in general, curved surface yung S sub k. Anyway, so approximation yung parallelogram, which is given by the norm of the cross product of these two vectors. At tapos, from our recall earlier, these two quantities, yung dalawang vectors na to, are approximated by these two expressions. So this expression here can be approximated by this expression in the next line. And finally, using properties ng cross tsaka norm, these delta u tsaka delta v, scalar sila. So, pwede sila ilabas dito sa cross product at tsaka sa norm. Okay, so we have this expression for the approximation of the area of one patch or of one S sub k. Ayan, so an approximation for the total surface area of S, which we will denote by A of S, is simply the sum of all such expressions over all k. So approximation pa lang to. So ang gagawin natin para lumiit yung error dun sa approximation na yun, yung usual na we increase the number of subdivisions of the rectangle D. Okay? Okay. So, we increase n such that delta u and delta v goes to 0. So, we get this exact value for the area of S. It's the limit of this sum as n goes to infinity. Pero itong sum na to, it's a Riemann sum. So, yung limit nito as n goes to infinity will be a double integral. Specifically, it will be the double integral of Ru cross Rv over the region D. Okay, so we have derived a formula for the surface area of a parametric surface. So, pakialala na lang, double integral ng Ru cross Rv over the region D. So, D here is the region in the UV plane where the parametric surface is defined. Okay, so for example, let's find the area, the portion of R of UV equals 4u plus 5v, 1 plus 3v, 2 minus 3u, traced by points UV satisfying these inequalities. Okay, so ang given sa atin dito, isang parametric surface over or defined over a region na nasa UV plane. Ayan, so dahil parametric surface ang given sa atin, we apply yung formula na kakaderive lang natin, which is this one. Okay, so take note, it's double integral of norm of Ru cross Rv. So para mas maayos yung pag-compute natin, isang usual way ay focus muna tayo dito sa integrand. Compute muna natin itong integrand. So in other words, we first compute the norm of Ru cross Rv. So para magawa yun, unahin muna natin yung Ru tsaka Rv. Okay, so this is R. R sub u is, take note, 4, 0, negative 3. R sub v is 5, 3, 0. Ayan, so yung Ru tsaka si Rv. And kunin natin yung cross product nila, which is 0 minus negative 9, 9, 0 minus negative 15, tapos sinenegate, tapos 12 minus 0. Ayan. So we have that. Okay, so ito si Ru cross Rv, tapos kunin natin yung norm. Okay? So ginagawa natin ito kasi ito yung integrand ng formula natin. Okay? Okay, so getting the norm of this cross product, we get this, which simplifies to 15 square root of 2. So for this example, yung norm of Ru cross Rv, constant lang, though in general, function siya of u and v, in terms of u and v siya. Okay, anyway, proceeding. So integrate natin for this example, 15 square root of 2 lang. So, to get the surface area na gusto nating hanapin, we just get the double integral of Ru cross Rv, this 15 square root of 2, over the region D. Pero ano yung D dito sa example na to? So, dito, again, D is a region, diba, in the UV plane. So, yun yung region na dinidescribe nitong inequalities na to. Pero looking at these inequalities, since yung U bounded lang by constants and V bounded din by constants, these inequalities describe actually a rectangular region. Ayan, so in the end, we just compute the double integral of this 15 square root of 2 over this region D. Okay, first, itong 15 square root of 2, constant lang, pwede siya ilabas sa double integral. Okay, so 15 square root of 2 times double integral na lang ng 1 over the region D. So, one way to evaluate this is to set up yung bounds for U and V. So, dA, gagawin natin du dV. Tapos, we set up appropriate bounds. Again, sa UV plane to Okay, pero another approach para masagutan to, imbis na mag-set up tayo ng bounds dito sa double integral na to, we use yung isang application na kaka-discuss lang natin. Diba? Ang double integral ng 1, diba? Ang sabi natin before, ang binibigay nito ay yung area ng region D. Okay? Pero the thing is, yung area ng region D for this example, madaling makuha since simple lang naman yung shape, diba, ng region D. It's just a rectangle. Ayan, so dahil dyan, we can simply replace this area of D by yung area nga ng D na using geometry lang, simple geometry. So the area of this rectangle is given by 2, length times width lang. Ayan, so with that, the value of this A of S is 15 square root of 2 times 2 or 30 square root of 2. Okay, so again, in-apply lang natin yung formula, okay, for finding the surface area. Tapos, dito sa computation na part, in-apply lang natin yung kakaturo lang sa atin na double integral ng 1 ay area ng region D. Okay. Pero hindi naman required yun. Kung gusto nyong mag-set up pa rin ng bounds, okay lang naman, syempre. Okay, next. Find the area of the portion of the surface defined by the vector function r of uv equals u plus v, uv, u minus v. For points in uv satisfying u squared plus v squared less than or equal to 6. Okay, so again, parametric surface ang given sa atin. So, i-apply lang natin itong formula. So, parang sa example actually earlier. So, we first compute the integrand. So, start tayo sa RU, which is 1 v negative 1v1, sorry. Then r sub v is 1 u negative 1. Ayan. Tapos, kunin natin yung cross product nila. Okay, cross product ay negative v minus u. Tapos, negative 1 minus 1 as sinenegate. Tapos, u minus v. So, we have this. Ayan. Tapos, kunin lang natin yung norm. Applying yung formula ng norm. And simplifying, you will end up with this expression. Okay? So, diniretso ka na. So, ito yung lalabas kapag kinuha yung norm, tapos sinimplify yung mga bagay-bagay. Okay? So, again, yung norm ng RU cross RV, yung integrand, in general, expression siya in terms of U and V. Ayan, so ito na yung integrand natin. We will integrate this over the region D, where kung saan define yung R of UV. Again, yung D dito, yung region na dinidescribe nitong inequality na to. Pero looking at this inequality, this describes a circular region sa UV plane. So, yung area of S, or parametric surface, is the double integral of this RU cross RV over this region D. Again, sa UV plane ta. Okay, so take note, dahil yung ating region ay circular region, mukhang okay gumamit dito ng polar coordinates. So, setting up bounds using polar coordinates, we have the following. So, yung 2u squared plus 2v squared maging 2r squared. dA will be r d theta. R will be from 0 to square root of 6, yung radius ng circle. And theta is from 0 to 2 pi. So, again, galing lang to dun sa double integrals in polar coordinates natin. Gagana rin siya kahit nasa UV plane yung ating region. Okay. Ayan, tapos to integrate this, we just use u substitution. Let u equals 2r squared plus 4. du will be 4r dr. Ito na yung bagong integrand in terms of u, or ito na yung bagong innermost integral in terms of u. Integrating, evaluating sa endpoints, simplifying, integrating ulit with respect to theta, and evaluating sa endpoints, we get this answer. Okay? Ayan, so, again, pakialala lang kapag parametric surface ang given sa atin, tapos gusto natin hanapin yung surface area niya, apply lang natin yung formula na to. So, kailangan alam natin yung R, alam din natin yung region D kung saan defined yung ating parametric surface. So, again, yung D yan nasa UV plane siya.